Hello everyone, I'm Sunanta from SNS College of Technology, Department of Mathematics. As the continuation of the lecture series in the topic statistical data representation, in this video we are going to see what is relative frequency distribution. So before that, let us brush up what we have seen in the previous videos. So first is the frequency. So what is frequency actually? Frequency is the organizing of data in a proper manner for the interpretation purpose. So in that we are having four types: grouped frequency, ungrouped frequency, cumulative and relative. So in this video we are going to see what is relative frequency. So next we'll be seeing the applications of this in the video. So here is the learning objectives of this video, in which we are going to see, we are going to define the relative frequency, calculate relative frequency using formula, construct a complete frequency distribution table, interpret the percentages from statistical data, applying relative frequency in real world application situations. So here is the frequency. What is frequency? A frequency distribution is a systematic arrangement of data showing how often each value or range of values occur in a data set, so which transforms raw data into an organized data that reveals patterns and trends. So here the key components will be classes, frequencies and total observations. So these are the types of data what we have seen already. So here is an introduction to relative frequency. A relative frequency is the proportion of observations in each class compared with the total number of observations. So instead of asking how many students scored in this class, we can ask what percentage of students belongs to this class, like that. Mathematical formula will be frequency divided by total number of observations, like RF, relative frequency, is equal to F by N into 100. So if you need this in a percentile, we can use this 100%. Otherwise, F by N will be NF. For example, if 15 students out of 50 belongs to this class, next relative frequency will be 15 by 50, which will be 0.30. In percentage, it will be 30%. This is a complete example. So in this table we can see this is the same problem which I have taken in the previous video. So in this, first the courses are there, then frequencies are calculated. So the relative frequency will be the 3 divided by 50, 7 by 50, 15 by 50, 18 by 50 and 7 by 50. For that the relative frequency is calculated. For the same we have calculated the cumulative frequency and cumulative frequency percentage. So next one will be the design thinking in statistics, empathize, and the thing is, so what is the purpose of relative frequency? So before creating frequency distribution, consider who collected this and what questions the stakeholder is trying to answer and what decisions will be made based on these statistics. Next, the clarifying problem. Clearly articulate what insights you need from the data. Are you looking for central tendencies, outliners, distribution patterns, or comparative analysis? So here is the construction of a relative table, in which they are given with the weekly study hours of 40 graduates. So from this we can first grade this into a study hours, next frequencies, next relative frequencies are calculated for the same. Next will be the visual representation of the same. Here is the design thinking ideate, prototype and test part, in which brainstorm multiple ways to present frequency data, which are tables, charts, infographics, like that we can present the data. Next, prototype will be create draft frequency tables and visualization. Test part will be validating your frequency distribution with stakeholders. So here is one research application in which the spending range is given. Next, how many customers spend in that range, and the relative frequency is calculated by the same formula, F by total. So 45 by 200, 22.5%, like that. It is calculated for all the values. Next is the key concept mind map of this. First we have identify the data collection, next frequency table, next relative frequency, and we can also find a cumulative relative frequency. Next is the visualization, so in which we can represent the data in form of graphs. Various types of graphs are there. Next, charts for insights. Next is an interpretation. So drawing the meaningful conclusion will be the interpretation part. So here is the key summaries of what we have seen. Thank you.